Hi there. Okay, in this video I'm going to share with you how to find a stationary point by using a differentiation method. Okay, for this question we are going to find a stationary point. Okay, so now the first step is we have to find the differentiation of this line, okay, of this equation. So differentiation here, this 3 we move in front, it will become 3 over 3, and x here minus with 1 is a normal differentiation method here. So here becomes 2. The 2 will multiply with 4 will become 8x, and here you have 12, and differentiation of a constant you'll be getting 0. So your differentiation here will be x square minus 8x plus with 12. Okay, this is a differentiation. Differentiation means it is a gradient, it's a equivalent to gradient. Okay, now the gradient will be 0 when you have a straight line. Now example, for this cubic equation we will have a cubical graph shapes. Okay, so here along this cubical graph there will be a lot of gradients value. So there will be a positive, there will be a negative, there will be a positive, and there will be few stationary points depending on the type of the equation. So here you have like a two types of stationary point you can find when your dy dx reaches 0, is equals to 0. So these points is what we have to find for now. Okay, this is the value of the x we are going to find. Okay, now we will proceed with this process. Okay, as I have explained just now, dy over dx equals to 0. So this equation we have to bring it to make it equals to 0, and we have to factorize this equation to find the value of the x. So here we will be getting x, okay, x is minus 6, and here will be x minus 2, where you will be getting here x is equals to 6, or x will be equals to 2 over here. So, and in these two coordinates you will be getting a stationary point. To find your x, you just have to take this value of this x, 6 and 2, and substitute into this original equation. So remember, this differentiation here is our step 1. Okay, now we are going to the step 2. So step 2 here is we have to find the coordinate of the stationary point. So we just have to substitute. In the earlier process we got the value of x. Now we have to find the value of y. Okay, so what we are going to do here is we just have to take the value of x over here 2 and substitute into every x over here to obtain your y value. So after we have substitute the x equals to 2 here, we will be getting y as 15, 2 over 3, or you want to change it into a decimal number, it becomes 15.67. Okay, same thing you have to do it for your x equals to 6, where we will substitute into this every x over here, and we will be getting the answer y is equals to the y will be equals to 5. Okay, so now we have actually obtained the stationary points over here. So there are two stationary points we have to know for this curve. Okay, now we are at the part 2 of a stationary point. Okay, where we will be learning here minimum point minimum point and also maximum point. The minimum point of a stationary, the minimum stationary point here will be in this shape. You just remember it as a smiling. Okay, and this is a stationary point x1 and y1. However, the maximum stationary point will be in a set face. Let me draw it more properly. So it will be in a circle, and here is the stationary point. So here will be x2 and y2 over here. Okay, so this part, this second part of the stationary point, it is not covered in IGCSE mathematics, but of course is included in IGCSE at maths. Okay. Okay, so now I'm going to find the minimum and maximum stationary point from this previous question that we have go through together. Okay, to find a minimum or maximum stationary point, what we have to do is we have to find the second differentiation of this equation. After we have find this, okay, after we have find this one, then we have to substitute the stationary point that we already obtained when we have a dy dx equals to 0. So let's say we got an equation over here, is for example, and I got a stationary point which is x is equals to 1 or x is equals to let's say we just make it as a 3. So when I substitute 1, okay, when I substitute 1 here, it becomes a positive. So I'll be getting a positive 3. So if you have a positive sign over here, it means it is a minimum. Okay, so your x1, the coordinate here for the stationary point is a minimum graph. And then when you substitute this x is equals to 3 into this x here, it will become a negative sign. It will become a negative sign where you will be getting here negative 1. So it shows it's a maximum value. So you will be getting x equals to 3, and this is a maximum. Now I'm going to show you from the previous example how I'm going to do this minimum and also maximum stationary points. Okay. Okay, this is from the previous question. So we already managed to get this dy dx of this curve, and we have the stationary point. So we'll be focusing at x is equals to 2 and x is equals to 6. So here again we have to do another differentiation. Okay, and then you'll be getting your answer there, 2x minus 8. So when we are substituting this 2, when we substitute 2 here, so I just put here x is 2, and then your differentiation here, second differentiation here will be 2 multiplied 2, you got there 4 minus 8, you'll be getting a negative answer. So this one is a maximum. This is a maximum point. Okay, now we will be doing the same thing with x is equals to 6. So differentiation here, second differentiation here, the value will be the 6 we substitute inside over here. You will be getting that 12 minus 8. You will be getting the positive 4, which means here you will be getting a minimum point. So basically your graph will be, let me extend this slide. Okay, so basically here we will have x is equals to 2, and here will be x is equals to 6. At 6 here, the graph shape here mostly will be, here's maximum and here is minimum, so you can draw in this way. Alright, so I just erase this 6 and 2 here. I make it like more accurate. So here you have x is 2. It shows it's a maximum point. Okay, it's a maximum point over here of the stationary. And here in this part, here you have x is equals to 6, which shows it is a minimum. Okay, so this is how we will decide the maximum and also the minimum point. Okay, for in this video, okay, here I will be showing a summary of what we have learned in this video. Okay, equation is the y. Okay, to obtain your stationary point, we have to find, the first step is a dy dx, and then we have to make your dy dx equals to 0. Okay, this is the first one. This is the second step, and then you have to find the most important part is, after you making it as a 0, find the x value. Okay, x is what? This is what it determines the stationary point, your x and y. Okay, the second one is to find the maximum and also the minimum point. We have to depend on a second differentiation of this equation, where the value of second differentiation for maximum will be a negative value and here will be a positive value. Okay guys, so I hope you enjoyed the video. If you like the video, please subscribe and like us. Thank you very much guys. All the best.